So we are going to discuss how we can calculate the pH of a solution. Alright. So pH of a solution can be calculated in multiple ways. So on this page we are going to discuss the pH calculation of a strong acid, strong base and weak acid, weak base. Alright. So let's come along. So pH of a strong base or a strong acid can be calculated as below. For a strong acid, pH equals to negative log H plus concentration. Alright. Now, as we know, H plus concentration equals to normality of a acidic mixture, right? So you can calculate pH of a acidic solution by putting formula as negative log normality of acidic solution. Again, for a base, how you can calculate pH? You can calculate like this for a strong acid. For a strong base, how you are going to calculate pH? You won't calculate directly. Initially, we'll calculate pOH. This will be negative log OH minus concentration. As H plus concentration for acidic solution is represented by normality, similarly, normality of a basic solution will represent OH minus concentration. Alright, so you can use the formula negative log normality for a basic solution, right? You get pOH, and let me tell you the total sum of pH plus pOH is 14. Alright, pH plus pOH is 14 in total. So if you have pOH value, then I think it is very easy that pH will be equals to 14 minus pOH. So for a base, we calculate the pH value indirectly. For a acid, you calculate pH directly. pH equals to negative log normality. For a base, you calculate is initially pOH, that is negative log normality of basic solution. Then pH you will calculate 14 minus pOH value, because pH plus pOH equals to 14. Alright. Next, you know that pH plus pOH equals to 14. So if a acidic solution is there, so H plus concentration will be higher than OH minus concentration. For basic solution, OH minus concentration is higher than acidic solution. For a neutral solution, both H plus and OH minus concentration will be equal. Alright. So these things are mentioned out here, and pH value will be according to that. Now, certain solutions are there where you will see that the solution is acidic but pH is coming greater than 7. There will be certain solutions when basic solutions will have pH less than 7. As you know, for acidic solution pH should be less than 7 and a basic solution pH should be greater than 7. So why does this happen? Acidic solution greater than 7 pH. This happens because these solutions are very dilute. So in such cases, H plus ions from water are also taken in account. Then you will get pH less than 7 for acidic solution, and for a basic solution you will take OH minus ions produced by water as well. Usually for concentrated solution we ignore H plus and OH minus from water. So always remember, if acidic solution is there, pH will always be less than 7. If for calculation you are getting pH greater than 7 for acidic solution, always look for the correct option which has slightly less than 7 option. Similarly, for a basic solution, pH has to be greater than 7. If for calculation it is coming less than 7, just look for the option which says slightly greater than 7, because we are considering H plus and OH minus ions from water as well. Alright. And further, we have, as you know, normality of a mixture into volume of mixture equals to normality into volume for one solution and normality into volume for second solution. This is the formula. When you have a mixture of solutions, you will be calculating normality of the mixture by using this formula. Alright, and we have discussed that Ostwald dilution law can be used for calculation of pH of weak acid and weak bases. Degree of dissociation for that comes out to be alpha equals to root of Ka by C, and alpha for a basic solution weak base will be alpha equals to Kb by C. H plus concentration for a weak acid comes out to be C alpha. So C alpha can be calculated putting alpha value like this, C into root of Ka by C. If I take C inside, so what you get is Ka into C square upon C. So this cancel out. So you get root of Ka C. So if you want, you can calculate pH of a weak acid like this, negative log root of K into C. Or similarly, you can calculate pOH for a weak base like this, negative log root of Kb into C, where C is concentration, K is dissociation constant of a weak acid, and Kb is dissociation constant of a weak base. So you know pOH value for a weak base, you find out pH by using this indirect formula, pH equals to 14 minus pOH. So for a acid you will get direct answer, for a base you will get a indirect answer. So in this manner you can calculate a strong acid pH, a strong base pH, weak acid pH as well as weak base pH.